We're going to start getting into some statistics and taking a look at some different distributions and data sets and take a look at mean and something called standard deviation. Now, typically coming into this class, you should know a little bit about mean and standard deviation. If you'd never heard of standard deviation before, we're gonna kind of review it in this lesson, and then we're only going to do up to the calculator stuff on this video, and then the calculator stuff we're going to do in class tomorrow. So let's see here. So we're going to just review a couple definitions here. Mean and standard deviation. The mean is like the average. It's a typical value of a data set. All right, so think of a typical value where the average, right? It's the balance point of the set. That is the point where the sum of the deviations to the left is equal to the sum of the deviations to the right. So if you add up all of the numbers to the left and add up all the differences to the left and all the differences to the right, that should be equal. Okay, if you have easy example, if you have an 85 average, right, and you have an 80 and a 90, 80 and a 90 is going to make an 85 average. Okay, and an 80 and 100 is going to make a 90 average. Why? 10 each way. That's just an example with 2 scores. But you could do it with, if you had 5 scores or 20 or 100 or 1,000, it would be the same thing. All right. So now, standard deviation is one measure, and that's the one we're going to use the most, of the spread or variability in a data distribution. So standard deviation measures how spread out a data set is. And we're going to look at, to help understand deviation, we're going to do this example right here actually. So take a look at test scores, because I think we're used to, that's one statistical thing that we're used to looking at, right? So we have Michael and Jose. Michael's math scores are 52, 53, 75, 95, 100, okay? Jose's math scores are 72, 73, 76, 76, 78. Now, both of them have the same average. Close, you could tell it's close to the same average. It turns out, and I did this purposely, they actually have the exact same average. If you have a calculator with you, add up Michael's scores and divide by 5, add up Jose's scores and divide by 5, you're going to get 75 for both of them. So Michael and Jose both have a mean, an average, a mean of 75. However, if you look closely at their individual scores, Jose has Michael has a much larger spread in his scores than Jose does. Jose's always around 75, so he averages 75 by being always consistently around 75. Think of consistency. Michael's not consistent. He's inconsistent. Up, down. He's like a yo-yo. Up, down, 100, 52, 95, 53, all over the place, right? His averages, his are spread out more. So the bigger spread you have, the bigger the standard deviation is going to be. That, I think, is going to help you understand the deviation the most. So what can you conclude about the deviations of these two distributions? Michael's standard deviation, let's put SD, is greater than Jose's. And to get the actual number, it's a very complicated formula. It's not really a complicated formula. It's just a long process to get the actual standard deviation number. We're going to rely on our calculator to do that for us. And I'm going to show you how to do that in the class tomorrow to get the actual standard deviation number. The calculator gives it right to you. You just got to type in the data, hit a couple buttons, and boom, it pops right up for you. Okay, so we're not going to, in this class, we don't really calculate the standard deviation just because it's time consuming. It could take you 10, 15 minutes, depending how big the data set is. The bigger the data set, the longer it would take you to calculate that standard deviation, the average of the spread of the data. So what we want to do here is just kind of use this video to be able to estimate and talk about a distribution and in words, kind of get a feel for what's going on in some distribution. So this histogram shows battery life in hours for different batteries, and the up and down is the frequency. You guys have seen histograms before, right? Just the bar graphs that are connected. When studying distribution, it's important to think about the shape, center, and spread of the data. So the shape of the distribution, the center, where the center is, and then how spread out the data is. Would you describe the distribution of battery life as approximately symmetric or skewed? Now, we didn't talk about that. This is something you may have picked up in Algebra 1, but you may not have. Approximately symmetric or skewed. Symmetric means like both halves are similar. If you go right down the middle, are both halves very similar as far as how many values are there. And skewed means there's more on one side than the other, okay, or one side has less than the other. So in this one, you know, the center of the data is right around 105, it looks like, right around here, okay? So let's just say about approximately 105. We're guessing. We're not, you know, this is just estimating here. Well, it looks like there's a good majority over, a good amount over here and a good amount over here, a pretty equal amount. So we would call that approximately symmetric, okay? Not exactly symmetric, because exactly symmetric means you have to have exactly the same number on both sides, okay? So it's approximately symmetric. And we would just say both halves are similar. So this says explain, so I would say approximately symmetric because both halves are similar. Now, on your paper, you can abbreviate if you want, but you know, if you're on a test or an exam, I wouldn't abbreviate something like that. I would definitely write it out in words. Okay, I'm trying to save you time on your video. Is the mean of the battery life distribution closer to 95, 105, or 115? We kind of already said the center would be about 105. So let's say 105 because why? Explain your answer. Because most values are around or near that. Most values are near 105. Okay? And again, we could get the actual mean if we wanted to calculate it, we could. Just estimating here. All right, so this one here, I'm going to kind of go back and forth. It's matching. All right, there are 4 choices, A, B, C, D, and there are 4 histograms. You have to match them up. Okay, so the choices are skewed and a deviation of 10, symmetric and a deviation of 10, symmetric and a deviation of 40, skewed and a deviation of 40. So we have to match them up. All right, let's take a look at these 4. Let's label them all, and then we'll figure out if it's A, B, C, or D later. All right, let's think about this. Pause the video and see if you can come up with it. All right, so I'm looking for tails. I'm looking for a tail. I see a tail here and I see a tail here. So I'm going to mark these as skew, and I'm going to mark these as my mounds. Mound shaped. Symmetric is mound shaped. Okay? Makes a mound. All right, so deviations, well, these numbers are hard to see on my screen, probably hard to see on yours, but you could definitely you could definitely see it on your paper. I believe this is at 90 to, yeah, this is a very small spread, 90, 100, 110. See, so this is the smaller spread. This is going to be the standard deviation of 10. This goes from 50 to 100 to 150. That's a bigger spread, so that's going to be a spread of 40. This one here goes 0, 40, 80, 1. See, it's a bigger spread. So that's going to be the 40 spread, and this is 70 to, only goes 70 to 120 total, 80, 90, it's going by tens. So it's a spread of like around 10, estimating from our 4 choices. So from this, mound and 10 was histogram 1. Mound and 10 was histogram 1, so that's B. All right. Skew 10 was histogram 2. Skewed and 10 was A, and that was histogram 2. And then we said mound-shaped and 40. Mound-shaped and 40 is C, and that was histogram 3. And then histogram 4 was mound-shaped and 40. Describe the shape, center, and spread of the distribution. Okay, so let's do that. First of all, this one's tough. I can almost argue mound shape, but there's certainly a skew here because it does tail off. It's a majority right here, and then it kind of tails off here. All right, it goes the center, like the center, and this is another reason you could tell. The center is like 20, 25-ish. Well, let's say 20, 23 right in here. Okay, but then it goes all the way to 50. See how, and that's a big difference. Where here it only goes to 10. Like that's only a 10 difference. This is tailing way off to 50. So I would say this is skewed to the right. Skewed to the right. And then I would say that's the shape. The center, we're going to use a approximate symbol. We're approximating. We can't say for sure. And your answer is going to be different than everyone's going to have a different answer here while you're watching the video, so it's going to be the same. But there is not one right answer here, okay? I say the center is somewhere around 25. I was kind of saying, right? 25, 23 maybe. I'll put 23, okay? You might put 22, 21, whatever. The spread is the example, or what you think the deviation is, where a typical value might be, okay? And I'd say 10 each way-ish, approximately 10 each way is the spread. Again, we are just estimating here. And then one more. This one, it looks more mound-shaped to me, okay? So if this is the center here, it's about, it's mounding off equal both ways. So I would say mound-shaped here. Mound shaped, okay, and I would say a center, what do you think, approximate center of 90-ish, okay, 90-ish, and how about a spread of, I don't know, let's see, so if 90-ish is the middle-ish right here, I'll say a majority of values are, I don't know, right about here to here. Okay, this is typical distance away from the mean. All right, so 10 each way-ish, probably 10 or so would be, again, just estimating the spread. In other words, you might put 12, 15, 20 for the spread, maybe 8, 7, whatever. If you put 60, you're wrong, because 60 would be like 30, right? So like a typical distance from the mean can't be 30. 30 is not even on the graph. So as long as you put something reasonable, you're okay. You got to put something reasonable. If it was a multiple choice question and they were asking you to estimate, the choices would be like, they wouldn't give you 10 and 11 as a choice, okay, unless you were calculating it on the calculator, which is what we're going to do in class.